Hey guys, we're just gonna do a little bit of review for the test. So I told you guys we're gonna do a little bit on um, bonds and all of that. So we're just gonna do a quick refresher on bonds, on valence, and on how to do Lewis dot diagrams. Okay, so chemical formulas, that was on your test too, where it asks you how many symbols there are, how many total atoms there are, and all that kind of stuff. If it's asking you how many symbols, it means count how many atomic symbols there are. How many elements are there? Not how many total atoms there are, but how many total elements. And the atomic symbol is the letters of the element. So if you get a question on the test asking you for the how many elements are there, you're looking for the letters of the element. And the letters of the elements are always capital, lowercase, if it's two letters. If you see something that is like N-O with a big O, two capital letters, that means they're two different symbols. If it's capital, then lowercase, like AS here for arsenic, it is one element. Okay, so that is something that you might need to know that might be helpful to you. It's asking you for how many elements, and you see a capital next to a lowercase, that's one element. You see two capitals next to each other, that's two separate elements. All right, the next thing we were talking about was bonding. We talked about this yesterday in SOD, ionic bonds. Okay, ionic bonds, you get the positive and negative ions in an ionic compound. So that means an atom has to give up an electron and become positively charged, and one atom has to take an electron and become negatively charged, and then they're stuck together. Okay? So they're going to give each other, one's going to give, one's going to take, and that's going to give us a bond, an ionic bond. Covalent bond is where they share. Okay, so co means share. It's just like co-champs. You share it. So you're going to share valence electrons. That's what covalent means. Covalence. Share electrons. Okay, that one's pretty easy to know. And some things can do more than one covalent bond. They can do double bonds or triple bonds. And one thing that can do triple bonds is nitrogen. Okay? Nitrogen can do a triple bond, and so can carbon. There's very few things that can triple bond, and that's one of them. Valence. Okay, so the valent electrons, I have to fix this really quick. Valent electrons are electrons that are the outermost electrons, okay, in the outermost energy level. They are the ones in the outermost energy level, and then we're going to make Lewis dots for that. So we're going to go over how to do this, okay? So I'm going to bring up my paint here. Okay, to do Lewis dot diagrams, you're going to show me the valence for B. To find the valence electrons, you go to the periodic table, you go to B. Here's B right here. You go to the row it is in. It's in row 2. And you count boxes from left to right, starting with the first row, till you get to it. And that's how many valence electrons it has. So boron has 1, 2, 3 valence electrons. So you do, and you start at the top, 1 dot per side at a time. Imagine it's in a little box. 1, 2, 3. Okay, boron has 3 dots. How many single electrons does boron have? It has 3. Single electrons means it doesn't have a pair. And if it has a single electron, that means that that's how many bonds it can make. It can make 3 bonds because it has no friends here, okay? So then for nitrogen, go to where nitrogen is. It's also in row 2. Count 1, 2, 3, 4, 5. Nitrogen has 5 dots. So we start at the top. Single, 1, 2, 3, 4. And now we start to pair them up. 5. So nitrogen has 1, 2, 3 single electrons, just like boron. That means it can make 3 bonds. Okay? Going over to sulfur. It's in the third row. 1, 2, 3, 4, 5, 6. It has 6 dots. 1, 2, 3, 4, 5, 6. Okay, so it can make 2 bonds because it has 1, 2 single electrons, means it can make 2 bonds. Okay, Mg. Find Mg. I want you to do this one. Easy. 1, 2. That means it gets 1, 2 dots. It has 2 single electrons. Can make 2 bonds. Last one is argon here in row 3. 1, 2, 3, 4, 5, 6, 7, 8. We go 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, it has 1, 2, 3, 4 pairs. That means it has 0 unpaired electrons. If it has no unpaired electrons, it can make no bonds. Okay, so this is what valence means. These outer electrons are put onto your Lewis dot diagram, and then you look at how many single electrons there are, and however many single electrons, that's how many bonds that that particular element can make. Okay, so I want you to make sure that you've written these down on your binder paper. Okay, I want you to have it just like this across the top. Okay, so you're going to copy just like this. Single electrons, number of bonds, above that, your Lewis dot diagrams, and tell me how many single electrons and how many bonds each one can make. Okay, and then we're going to move on to the rest of the activity for today. There's just one more bond we have to go over, and that's a metallic bond, and that's when metal atoms share their electrons. We talked about this before. Basically, it means that you get the nuclei of the atoms, okay, the protons and neutrons, and the electrons, the negative charges, are spread throughout the entire material. Okay, and that makes the ability for metals to conduct electricity and heat very, very easily because those currents can move through because those electrons are not stuck and the atoms have freer movement than they would normally. Okay, now you guys are going to look up at the front board and do what the front board tells you. You're going to go to my website and do some games and write down some more stuff on your binder paper. You are only going to need 1 sheet of binder paper for this part, so just follow the directions and hopefully this review session will help you out for the test.